radius of curvature, which is the distance from the pole of the mirror to the center of curvature. Then we discuss the principal focus or the focal point, which is a point on the principal axis where rays that are parallel and close to the principal axis actually converge or appear to be diverted from after reflection. Then we also discussed the focal length. The focal length is the distance from the pole of the mirror to the principal focus or the focal point. Principal axis, a line passing through the center of curvature and through the pole of the mirror extensively. So these are the key parts of the spherical mirror, whether concave or convex. Yesterday, we also discussed the advantages of convex mirror over the concave mirror and the plane mirror, and the reasons for which it is used for purposes of the side view mirror of the automobiles, used for security, surveillance and security in the supermarkets, and those other. So these are the key advantages or concepts which you must look at. Today, let's look at formation of images. Formation of images in spherical mirrors. Images in spherical mirrors. Our concept is still under mirrors. Here we are looking at spherical mirrors. Let me quickly upload attendance and then get back to you. So back to you. So formation of images in spherical mirrors. We'll look at how images are formed in concave. And when we finish, we'll look at how images are formed in convex. So to form images in concave mirror. A concave mirror, hold on, okay. A concave mirror produces about 95% real images. It is just in one instance where it forms a virtual image. So most images formed are real images. So in image formation in concave mirrors, you must draw the mirror, shade that part so that we have an idea of the nature of the mirror that is being used. And when you are drawing this, in fact, mirrors must be drawn with small aperture. So just a small aperture something. You don't draw a mirror which will look like an umbrella. No. Then you rule a vertical line behind it. You draw a vertical line behind it. The function of this vertical line is to cater for reflections that go beyond the aperture of the mirror. Because originally, you are drawing, mirrors have just small aperture, so you are not to draw anything so big like an umbrella. Just small something, indicate the shaded area, but you rule that vertical line behind it to cater for reflections beyond the aperture of the mirror. Okay. Then you measure the focal length. Now R is equal to 2 times F. The radius of curvature must be twice the focal length. So if I'm to measure, or if I'm assuming that let the focal length be X centimeter from the pole, then the center of curvature must also be X centimeter from the principal focus. So here you take measurements. You must measure. You must choose a value yourself to measure. Maybe let F be equal to 5 centimeter. Then the radius of curvature, which is 2 times F, would be equal to 2 times 5. This is very important. If you don't do that, location where the image will be formed will be wrong. So take note. I am not measuring because I don't have what it takes to measure, but you must take measurement. Class, is that okay? Hello, is that okay?
Yes, sir.
Please. Yes, sir.
So having done this, you see, I've indicated my principal focus. I've also indicated my center of curvature. Then for concave mirror, various positions of the object would give you different characteristics of images. Okay, so the object distance can be beyond the center of curvature. So 1, object position can even be at infinity. Two, in between C and infinity, or beyond C. the object positioned beyond the center of curvature is the same as place between infinity and C. The object position can also be at C, at C, for it can also be positioned between C and F, and we'll do it for all these positions, okay? The object position can also be at F. And lastly, object position can be between the pole P and F. So we use ray diagram to describe the nature of the image formed, okay, as object is placed at these various points on the principal axis. Now, in using ray diagrams to describe the nature of images formed, there are rules of the game. There are rules. So let's quickly go through the rules. The first rule is that, you see, the rays are always coming from the objects. Rays are always coming from the objects. We see, as human beings, we see as a result of reflection. To see something, light must incident on the object and then reflected into my eyes. Okay, so to see your friend, light from the sun or any other available source must illuminate, shine. Illuminate means shine on the object. And the beam of light which is illuminated on the object is reflected from the object into your eyes. That is how come we can see this, and this is the reason why when there is no light at a place during darkness, you can hardly see. It means that light does not come from the objects around and then reflected into your eyes. So we see as a result of reflection. So the rays must always come from the object. So one, the first rule is that a ray of light always from the object, parallel to their principal axis. When a ray of light from the object is parallel to the principal axis, after reflection, it must pass through the reflected ray. After reflection, it must pass through the principal axis F. So that's the first rule, or one of the rules. A ray of light which is parallel to the principal axis after reflection must pass through the principal axis F, or the sorry, did I say principal axis? The principal focus, sorry. The principal focus. F. the principal focus or the focal point. Then the second rule is that a ray of light from or passing through the principal focus, a ray from or through the principal focus after reflection must be parallel to the principal axis. This second rule is the reverse of the first rule. Is the reverse form of the first rule. Light obeys the principle of reversibility. So if the ray is parallel to the principal axis, after reflection, it must pass through the principal focus. And if a ray of light from the principal focus or passing through the principal focus after reflection, it must be parallel to the principal axis. I'll give a sketch of all this. Then the third rule is that a ray of light incidenting on the mirror, a ray of light incidenting at the pole of the mirror must reflect at the same symmetry as the incident ray. Permit me to clear this position and then write the last rule. Then the last rule is that for a ray of light incidenting on the mirror normally or perpendicularly the last word is incident, okay, at the same must reflect at the same symmetry as the incident. So the last word is as the incident ray, okay? And a ray of light that incident on the mirror normally or perpendicularly must reflect back along the same path and converge or pass through the center of curvature C. So these are the 4 rules that will be used in array in image formation. Elikem.
Please, is CP equal to 12?
C is PC. PC, that is equal to, PC is equal to the letter R, the radius of curvature, and R must be equal to 2 times the focal length F. Are you okay?
So it's equal.
Come again.
So PC is equal to 2F.
Exactly. Okay, it is PC because all measurements must be taken from the pole. So when you are measuring every length, it must start from P. All right, can I flip to the next page?
No,
No,
please.
sir.
Hurry
No,
up,
please.
hurry up. So these are the rules of the game. We'll be using any 2, at least. Any 2 would help us form an image. We don't usually use all of them. Any 2 rules well applied must help us get the image and then describe.
Recording in progress.
Let's please hurry up, okay? Angela.
Sir, please, can you please explain the object position at infinity again?
Oh, don't worry. I will be going through each one of them. So relax, okay?
Thank you, sir.
Okay. Can we move on? Those of you writing, can we continue?
Yes, sir.
All right. So let's understand how these rules actually work out. How do we use these rules? 1, a ray of light which is parallel to the principal axis after reflection must pass through the principal focus. So this my mirror is a concave mirror. So you must indicate the pole, then measure F. Get a value for yourself and then measure F. Then PF must be equal to FC. This is very important. So a ray of light coming from the object, if the ray is traveling parallel or is going parallel to the principal axis, then after reflection, once the ray is parallel to the principal axis after reflection, it must pass through the focal point or the principal focus, F. So this is how the first rule works. Then the second rule is just the reverse form of this first rule. I'm taking my time to draw the ray diagram for each one of the rules so you can understand and apply. In each case, I must carefully measure the focal length iPhone, please mute yourself, okay? iPhone, what's your name?
Daniel.
Okay. Daniel, say.
Ado.
Yes, Ado. Okay, so the second rule, which is the reverse form of the first one, a ray of light, wherever it's coming from, it may come from up here. It must always come from the object. If the ray is passing through the principal focus, so the ray must be passing through it or from. Once it is through the focal point, then after reflection, the reflected ray must be parallel to the principal axis. So arrow to indicate incident, arrow to indicate reflection. This is the second rule of the game. The third rule, I'm not drawing the vertical line because this is not a ray diagram yet. I'm just going through the rules. So there's a pole. Carefully measure the focal length. Then carefully measure the radius of curvature. Then a ray of light which is hitting the pole let me reduce that angle because of the space below. Once the ray is hitting the pole, it must reflect at that same symmetry. It must also reflect at that same symmetry. What do we mean by the same symmetry? Look at this angle. Okay, there's the incident, there's the reflected. This angle between the principal axis and the incident ray must be the same as the angle between the principal axis and the reflected. And because I did not estimate it well, we are even realizing that this upper angle is greater than this. So I must still make it look better. So that is what we mean by at the same symmetry. So this angle must be the same. So sometimes if you are applying this rule, you can even use protractor to take your angular measurements so as to be accurate. So this is what we mean by the same symmetry. Then the final rule, which is the fourth rule. The fourth rule, please, let me pick this call and then get back to you. Very important call. Okay, so the last rule of the game. So this is how the rules actually work out for concave. Or converging. F. So pole is here. And then the center of curvature. Please, when you are doing this, take measurements. If you are not given exact values, take values yourself and then apply the rules. So a ray of light which is hitting the mirror at an angle of 90. No matter where it is coming from, must one, reflect back along the same path, and two, converge or pass through the center of curvature. So it means that the ray can come from above. Here it is coming from above. The ray can also come from below, but the moment it hits the mirror at an angle of 90, it must reflect back along the same path and pass through the center of curvature. This ray is coming from, yes, below. And I'm doing this to let you know that the ray can come from above and below. All that matters is that it must incident on the mirror at an angle of 90. So when you see a ray passing through C and then having the arrows along that same path, then it simply means that the ray is intersecting on the mirror at an angle of 90 degrees. That's basically, so this is how the 4 rules actually works out. Any question? Angela?
So please, I don't understand the rule number 4, how the rays are hitting it at 90 degrees.
So no matter where the rays are coming from, okay, when it's incident on the mirror at an angle of 90, it must reflect back along the same path and pass through the point C. So all that it requires is that the coming ray must incident on the mirror at 90. How that will be done, Angela, is not your problem. So when you see a ray of light coming back along that same path and passing through the center of curvature, then it implies that the said ray is intersecting or hitting the mirror at 90. As to how it will come about, Angela, that's not your problem. Is that okay? Hello? Hello, Angela? Oh, she's gone. Okay, so all these are for concave. And you need just 2 of these rules to form an image. If it's convex, how does the rules work? So for convex, the reflecting surface curves outwardly. Janelle, are you there?
Yes, please.
Okay. Is Angela back?
Yes, sir. Sir, please, it was my network.
Okay. So don't forget, for convex mirror, the center of curvature is within. So if the focal point is also within, it's virtual. The same rule, R is equal to 2F. Let's extend the principal axis a little bit. So for convex mirror, a ray of light parallel to the principal axis after reflection must pass through, must appear to pass through F. Appear to because it's a virtual thing. So before you draw the reflected ray, you must connect it to the principal focus. And we often use broken line for that. I don't have that. That's why I'm using a solid line. So this is the reflected ray. But the reflected ray must appear to be reflected from F. Let me draw another parallel ray to the principal axis. It must reflect, but the reflected ray always appears to be reflected from the principal focus, the virtual principal focus. This is how the first rule works out for convex. Then the second rule is the reverse form of the first one. Here, a ray from elsewhere must, must appear to be passing through F. The ray is coming from here. But the ray which is actually coming from that point must look like passing through F. And once it looks like passing through F after reflection, when it hits the mirror, the reflected ray must be parallel to the principal axis. Gideon. Gideon, your line is breaking. No, Gideon, fix your problem and come again. Oh, no. Gideon said, write it. So, the ray is coming from up here. Hey, Gideon. Here, what I'm saying is that the ray can come from a source above, but if the ray appears to be passing through F, then after reflection, the reflected ray must travel parallel to the principal axis. And that is the reason why I'm even clearing whatever is here. I'm clearing this part because the ray must appear to be passing through F. Okay. The reason for me using the broken line to fix this part, because it's not a real thing. It's a virtual thing. The ray appears to be coming from up or below and appearing to be passing through Earth. And after reflection, it must reflect and be parallel to the principal axis. Gideon.
It is actually the radar is going to catch Earth. It's supposed to be in broken lines.
Yes, because it's a virtual thing. It's a virtual thing. So that's why I've even cleared. But this one, okay, let me design this as how I have done the reverse rule. So it must end here. And the reflected ray can continue. So I can clear this part and then use broken lines because it's a virtual. The ray appears to be diverted from F. So this is how the first and second rules applies to convex. Is that understood? Hello? Class,
Yes, sir.
okay. Can I move to the next page or hold on? Can I or
Please
hold?
hold on.
Okay. I want to make adjustment. Once it's continuous, I cannot clear it. Please, for ray diagrams, class, do not forget about your straight edge. You must always use straight edge, okay, to look in order to have a very beautiful work. Do not use your free hand, no. You'll be penalized when you draw ray diagrams with your free hand. So this ray appears to be coming from above here, and it appears to be passing through Earth, and after reflection is parallel to the principal axis. This ray also appears to be coming from down here and also looking like passing through Earth. After reflection, it is parallel to the principal axis, just the reverse form of this one. So this is the second rule as applied to convex. And the moment you get to understand the rules, oh, you are good to go. Can I continue? Move to the next page. Yes. Yes. The third rule is that Frank, are you there? Hello, Frank. Okay. So a ray of light that strikes the pole Abenema, leave my board alone. I no go leave my board alone, okay? That strikes the pole of the mirror must reflect at the same symmetry or axis. No, this is not aesthetically nice for my liking. So let me come again. It must hit the pole very well. Okay. After reflection, it must reflect at the same axis. And here, as I said, you can use protractor to measure angles so that you can have it so well. Incident reflected. And these angles must be the same. And the third one, I'll put the fourth one on the, okay, once I'm doing that separately for all. This is the last one. So we'll draw. Frank had a question which is to be answered today, and he's not here. So when the ray hits the mirror at 90, then it must appear to be through this. Okay, let me draw this separately since I'll eventually clean this. So by this, what it simply means is that the ray is hitting the mirror at 90 and will reflect along the same path and appear to be passing through C. Must appear to be passing through C. A word of caution, do not use freehand for this. Okay, now let me use my solid line. Else it will compromise the neatness of the ray diagram. So this is the fourth rule. This is how the fourth rule also works for convex mirrors. Quickly, let's go into image formation. If you don't have any question, we are starting with image formation with convex. Can I clean these two ray diagrams? Can
No,
I
please.
hurry up if you are sketching? Please, when you are doing this, straight edge, your ruler, even pencil, well sharpened pencil, so that when you commit any mistake, you can erase and do the writing. Ray diagrams must be neat. It must be neat and beautiful. Let's hurry up. Gideon, go ahead.
So in the fourth row, so it means that a ray of light is not coming from the other side of the
Oh, I can
of
do
the
that.
mirror.
No, I can do that. Okay, it can be one. We can demonstrate it using just a ray or both, just to give an idea of whether the ray is coming from this, or that. So I can also do that. But the moment the ray hits the mirror at 90, then it must reflect back along the same path and must pass through C. So we can also do that. But don't forget, this is a virtual thing, so it must be drawn in a broken line. It must be drawn in a broken line. Can we continue? Class, can we continue? Oh, give me. All right. Our time these days is scanty, so please sympathize with me so we can be able to do more. So let's use ray diagram to describe the nature of image formed for concave, maybe one or two. Then we do one or two for convex as well. So here, mirrors are not that big. So the aperture must be something small. So the vertical line to cater for reflections beyond the aperture. And this time I'm ruling because we are coming to draw a ray diagram properly. F is here, take measurements. Maybe 5 centimeter, 10 centimeter, and from F to I am to estimate the same value, C. Now, I want to place the object at beyond C, or between infinity and C. This is the object. So object O is here. O represents objects. The object is not that tall. It can be taller. Okay, so we need at least two of the rules to form this image. And you are free to choose any two. A ray of light parallel to the principal axis. And here, when you are doing this, your parallel lines must be well drawn. Parallel to the principal axis. After reflection, must actually pass through Earth. It's a real thing. So incident, reflected. I need another to form an image. I can choose any. I can choose any of the two other rules. A ray of light from the object passing through or hitting the mirror at 90 must reflect back along the same path and pass through the center of curvature. I can use this. So incident, reflection. I can also decide to use a ray of light from the object passing through Earth after reflection must be parallel to the principal axis. That can also work. Or it can also come from, it can also hit the pole. Any two would help us here. Yes, Frank, that's why I was even calling you. Okay. Now, when an image is formed, whenever a real image is formed, whenever two reflected rays actually intersect. Look at the reflected rays. That's one. And this one. They are all intersecting at this point. Where they are intersecting is the point where the image will be formed. The point of intersection becomes the position of the head of the image. The foot of the image and the object is always on the principal axis. So the rays would intersect at this point. And so that point of intersection becomes where the head of the image is. So this is the image. The foot of always the object and the image is on the principal axis. Okay. So by this, we can, Angela.
Yes, sir.
Go ahead.
Sir, please, I don't understand how the second ray, the ray 2, was reflected back if it didn't hit the mirror.
Oh, Angela, your line was fading. I said that in ray diagrams, we don't draw a mirror with a very large aperture, a mirror like this, as if it's a half moon. No, that is not done. So you draw a mirror with a very small aperture. However, rule vertical line behind it to cater for rays that will go beyond the aperture of the mirror. Angela, do you understand?
Yes, please.
So that's exactly what I've done. And when the ray hits the ruled vertical line, is equal as hitting on the mirror. That is how
Okay,
come.
thank you, sir.
So when you see that the incident ray is passing through the center of curvature, then it simply means that the ray is hitting on the mirror at 90. And so the reflected ray must take the same path. All right. So let's describe the nature of this image form. 1, our image is real. Nature of the image. Image is real. Why is it real? It is real because it is formed in front of the mirror, or it is real because it is formed as a result of the actual intersection of reflected rays. It is real because it is formed as a result of the actual intersection of reflected rays. Now, all real images are inverted. Michael, please mute yourself. All real images are inverted. All virtual images are upright. So it is real, it is inverted, or turned upside down. Three, image is formed between Gideon. Yay, Gideon, your network. Gideon, send me a message. 3, image.
My question was, sir, can you hear me now?
Yes.
So my question was, why is it that sometimes you can see an image form in the air, like a live image in the air? So how is that formed?
Send your question to me, okay? I'll respond to it even after the class, okay? For the sake of clarity, the network is disturbing. Then the image is, look at class, look at the size of the object and the size of the image. Let's compare the size of the object, size of the image. What the So let's compare the size of the object and the size of the image. Angela, can you help me compare? Look at the size of the object, then the size of the image. What will you say about the size of the image form? Angela. Oh, Angela is not there. Yes, Gideon.
So it's a smaller.
The image, exactly.
The image is smaller than the object.
Good. So if the image is smaller than the object, technically, we say that image form is diminished. Image is diminished. Then the fourth characteristics of the image form is the position where the image is formed. Image is formed between the center of curvature and the focal point. So these are the characteristics of the image when the object is placed beyond the center of curvature or placed between infinity and C. Let's do another one. The rest will be given to you as an assignment, which you will do and send to me. Then, so after the two, we'll look at what happens for convex. Next week, I think I will discuss when the object is at infinity and then at F, because that is key. So when the object is placed at the center of curvature, so ray diagrams, a ray of light parallel to the principal axis after reflection must pass through F. Then a ray of light, I'm using the other reverse rule. A ray of light through F after reflection must go parallel to the principal axis. Good. You see, let me take it again because I'm not getting the precision right. This is what happens if you don't take your measurement well. So please, the caution is that when you are doing this, PF must be equal to FC. I said I don't have that chance to measure. So you must use your ruler very well to take. If you don't do that, you wouldn't get the exact location. And when you are applying the rule, make sure your ray is parallel to the principal axis. So you can use the grid line in your book to help you. So after reflection, the reflected ray must pass through F. Then you can use any of the other rules. It is this time it is the ray passing through C that can't be used because the object is at C. So you can't use that rule. Okay, but all other rules can be used here. Because the object is at C, you can't use a ray of light hitting the mirror at 90 and reflecting back. And this is better. You must please ensure that your ray is actually parallel. If it's not, it will affect the position of the image. So incident ray, reflected, incident ray, reflected ray. And the two reflected rays are actually intersecting here. Where they intersect is the head of the image form. And this is C. So let's describe the nature of the image form. Yes, can you help? What is the nature of the image form here? One, image is what? Let's not waste time, please. Image is,
Virtual.
come again.
Virtual.
Why is it somebody is saying virtual, somebody is saying real? Which is which? And let it to finalize it for us. The image form is it real? Is it real or virtual? It is real.
It is real.
It is real because it is formed in front of the mirror. It is real because it is formed as a result of the actual intersection of reflected rays. So image is real and all real images are inverted. Two. I've joined real and inverted. Go ahead, I'm listening. Two.
It is the same size. It is the same size as the object.
Okay,
It's
so
formed on the
image.
same side of.
Yes, image has same size as objects. Three, image formed at C at the same location as the objects. Okay, and so that's it. So when you place an object at F, yes, it's at C, it will be formed at the same position C. It will have the same size as the object. Okay, it will be the same size, the same height, and then it will be real, and all real images are inverted. For the sake of time, let's do about 2 for convex as well. I'm clearing the nature or the characteristics of the images form.